Hey, what's up, guys? So we're going over chapter three in the field engineering methods manual, and it's all about kind of field work and your best practices out there in the field. And it kind of starts off with safety. So we all know that our PPE is definitely super important. Um, that means we have to wear our glasses, our hard hat, our high vis boots, um, masks with all this COVID stuff going on, and we need to be the examples out there in the field as the field engineers. People are going to look up to us and see that we are Oakland, and with that, we have to be perfect in it. And we have to adopt that zero tolerance policy that Oakland has. As a culture, I've been on job sites where, superintendents or project managers or whoever let some guy with no glasses on just walk right by them, and it's not a big deal. But that's not who we are as Oakland anymore. We need to expect that everybody wears their PPE 100% of the time while working and while on the job site. We also need to understand our tools, make sure that they're in working condition, that they have all the right guards, um, that they're clean. Those are things that if they're not taken care of, they can lead to accidents really quick. Um, and we need to make sure that the weather is good enough for us, and that we're dressed for the weather, that we understand the weather for the day. Um, I've been working in Park City for, I don't know, the last 2 years or so, year and a half, 2 years. And, weather up there plays a huge part with all the snow and ice that we get because um, those pathways that we have and the access points we have, if they're covered in ice and snow, people start slipping and falling and they get hurt. And, and then we're not able to access the places that we need to with our equipment, and it's just a nightmare. So make sure that you understand the weather, that you're prepared for it, and everything is coordinated in that sense. And then signage, make sure that you have the right signage for your project, um, whether that's, I don't know, a flagger on site to help direct traffic, or whether it's closing, signage that says road lane closed here and whatnot, because I mean, that can be one of the most dangerous things on our job sites is pedestrians and other cars and whatnot, and we just need to mitigate that as best we can. And then soil disturbance. So soil disturbance, guys, it's huge. And us as field engineers, are we understand how to lay things out, but and that makes us very vital in this soil disturbance process because it also means that we can as build things. Um, so make sure that you're following the right process out there, that you're helping as build the utilities that you can and and should be as building. And I've been on projects where we've had incidences with utility strikes and whatnot, and it is the worst thing ever, guys. It's no fun to go through a utility strike and shut down the job because there's gas spewing everywhere, and now you got the fire department up there, and you just don't want that. And I know that if you follow the soil disturbance process to a T, which means painting out all your utilities at daily, um, identifying hand dig zones, identifying where you might need a spotter. Um, those kind of things will keep you from making a mistake. And then as field engineers, we need to make sure that our superintendents are reviewing those soil disturbance permits with us, because I guarantee that um, you're not gonna find something, and your super he'll find it for sure. They have more experience. They have um, a better eye for those things. And then don't disregard the soil disturbance permit, guys. Like, just because we're driving a stake, or we're just putting in, I don't know, irrigation lines, that doesn't mean we were exempt from the soil disturbance process. Those are the times that I've had some of the most um, dangerous and worse um, utility strikes, is just having carpenters drive stakes, and they're driving them 6 inches in the ground, and a utility is where it's not supposed to be, and is not as deep as it should be, but we still identified it with paint. And now you're in a big situation where if you had hand dug and found that utility, you would have never had this problem in the first place. So just make sure you're doing it and following the process perfectly. So, measurement principles: make sure that you understand that we don't burn a foot here at Oakland. We don't burn an inch. We don't mess with any of that, because we don't want to miscommunicate to our rodman or our partner, and come up with um, wrong measurements where we might be off a whole foot or whatever. And just don't do it. It's a communication thing, and it's just easier if we're all on the same page. And then make sure you understand what accuracy is and versus precision. So, if we're accurate, we're in the right spot with our measurements, and we're consistently, but we may not be consistently in the right spot, if that makes sense. That's where precision comes in. Precision is kind of where we have all of our measurements and all of our groupings or whatever in the same spot. So we want to be accurate and precise. We want to be in the right spot and consistently in the right spot. But make sure that you can identify when things aren't necessarily in the right spot and why they're not in the right spot. And then, mistakes versus errors. Make sure that you know that when you make a mistake, and that you're honest about it. Mistakes happen because of carelessness, and I'd say errors happen just because of the nature of what we work in. And being honest about those errors and mistakes. You're gonna make mistakes, but make sure that you learn from those mistakes and adapt and overcome those mistakes. And make sure you understand your errors and why you have those errors, why they come up over time, and what causes those things to occur. And then just be honest with your supervisor, your superintendents, your project teams, that they know what's happening out there and that you're clearly communicating that. Tolerances, we as field engineers, we shoot for perfection. But we understand that we may not be perfect, but that is what is expected. That's what I expect of myself, and that's what I expect of everybody else, is that they are trying for perfection. And then that when they aren't perfect in their measurements or their layout, that they understand why they're not, and that they adjust and then make their layout or measurement perfect. And kind of a rule of thumb is that your tolerance is about 1/8 of an inch. Kind of no matter what we do, 1/8 of an inch is about the most that we can be, the most error that we can introduce into our layout and our projects. Field notes. Make sure you're taking your field notes, and make sure you're doing them right. Number your pages. Make sure the weather's on there, the date, and don't erase anything. I like to use pen, or I use my iPad usually. But don't erase anything. Just simply put a line through it so that it's obsolete. But write everything down, and don't erase, because you may need that information later. When you're looking back through, you might realize that you were right and you had crossed it out. But I think the biggest thing about field notes is that it helps you learn. You learn to see where you're making mistakes, and it helps you understand what's going on out there. Make sure you're doing drawings of everything, all your layout. That if for some reason you all of a sudden fell off the face of the earth and all that was left on your project was your field book, you want to be you want to be sure that somebody could take that field book and just continue working and understand all the layout that was done on your project. People should be able to read your notes clearly, so write clearly. Don't just scribble stuff down. I'm probably the biggest culprit of that because I just have bad handwriting, and it's something that you need to work on. So speaking of bad handwriting, just one thing I do is I write in all caps, and that seems to help me at least make my writing clearer. And I know it's something that is super important that we can take good field notes. Kind of goes back to some of the things we've already talked about in past videos, that we need to write everything down, otherwise we will forget it. Don't expect everything to stay in your head, because it won't. And I think when a benchmark gets knocked down, or an elevation gets maybe scribbled over, you have that in your field book, and you can easily go back and recreate those points or those elevations, because you've already done the process once. You don't want to have to redo the whole process, and that's what the importance is of a field book, right? And then make sure you're taking care of your instruments. I think a lot of project teams and carpenters and stuff, and even field engineers, don't necessarily take care of their equipment, and guess what? Gets out of calibration quickly, and they're not safe, and it's just be careful with everything you have, and make sure that everything's calibrated. I was just out on another project a couple weeks ago where we were transferring grids onto a building, and the plumb laser was out, so we ended up off about an inch. And you could argue that we wasted 2 hours because we didn't check to see if that laser was plumb. But I think for me it was a great learning experience, because I was able to see that we were able to catch that error, and see that an inch off in 10 feet was a big deal. And we were able to work backwards and identify that problem and then fix it, and everybody was able to continue working and everything. And also check your hand levels. Don't trust them all the time. I know a lot of us have torpedoes or whatever, but make sure that when you do see an error, because most of the time you'll catch it with your eye that the level's out, that you dispose of that level after. Break it, get rid of it, trash it, whatever, or send it off to get calibrated if it's a digital laser or whatever. Make sure you know how to level an instrument. Kind of just basic things. 3 screw versus 4 screw on your builder's level will change your setup. I think most of the ones we use are always 3 screw, and then remember your rule of your left thumb. So whichever way your left thumb is going is most likely the way that level bubble is going to go. And then make sure you're turning your instrument once you've got it level, and double checking that it is level. Your total station and theodolite and stuff, you want to rough level it real quick, and then once you get your total station on, you'll start doing the fine tuning. And sometimes that's hard, because you still got to be dead center on your control point, and you're trying to get it level. And guess what? As you get it level, it will move um, where your plummet is sitting and where you're looking, where where your whole station is set up over. So you need to make sure that as you're leveling, you are still on your control point and make adjustments. And kind of continuing on with that's instrument setup, right? You know, we do our rough level and then we start fine tuning everything, making sure that we're set up over a point, and that if we do have to adjust the total station, we slide it as a whole. You never want to scoot one side and then the other, because it'll screw you up on your leveling and you're most likely not going to end up on your point. And just remember, we are the Badgers out there. We got to be the Badger and just make sure that we are kicking butt and everything. We need to be perfect in all that we do. I know that that's not realistic, right? But it's what we should expect from ourselves, is perfection, and then settle with near perfection. I think that it's important that we understand the best practices out there. I mean, this is a pretty quick overview of that, and I know that there's a lot of other best practices. So get out there, learn from each other, learn from your carpenters, because they know a hell of a lot more than we do, and make sure that you're humble, hungry, and smart. Thanks, guys.